Hello everyone, glad to see you in Lupus 2017 in Melbourne. My name is Wei Zhong. I'm working in the Department of Rheumatology in the First Hospital of Jilin University in China. It is a great honor for me to introduce my study here to you. As a young scientist in this area, I'm eager for your valuable support and I will appreciate your constructive advices a lot. A higher frequencies of T helper 22 cells in new onset active systemic lupus erythematosus. Systemic lupus erythematosus is an autoimmune disorder and affects many organs, including the skin, joints, the central nervous system, and the kidneys. In lupus, T cells, especially CD4 positive T cells, contributing to the initiation and perpetuation of autoimmunity, and seem to be directly involved in the development of related organ pathology. Infiltrating activated T cells are also found in tissue from involved organs such as the skin, kidneys in lupus. However, their direct role in contribution in tissue injury is still obscure. SLE T cells show inappropriate tissue homing and promote inflammation by secreting cytokines and chemical receptors CCR4, CCR6, CCR3, and CCR10. Chemical receptors have been instrumental in the characterization of subsets of human memory T cells with distinct migratory capacity and effector functions. Th cell population can be characterized by different chemical receptor expression. For instance, interferon gamma producing Th1 cells are CCR6 negative, CCR3 positive, and CCR4 negative. Interleukin 17 and interleukin 22 producing cells are primarily found in the heterogeneous CCR6 T cell population. CCR6 population with Th17 characteristics are CCR3 negative, CCR4 positive, and CCR10 negative, and the CCR6 cells with Th22 characteristics are CCR3 negative, CCR4, CCR10, and CCR6 positive. Previous studies investigated the relationship between Th subsize and SLE by identification of these cells with the intracellular cytokines they produce. In this study, we characterized the frequency of circulating Th22, Th17, and Th1 cells in 25 patients with new onset active SLE, and 13 gender and age matched healthy controls, with phenotypic, functional, and double tagging, including phenotypic and functional simultaneously, and identification by flow cytometry analysis for the first time. Furthermore, we discussed the underlying mechanism of their roles in the pathogenesis of SLE. A total of 25 new onset SLE patients were recruited from the inpatient service of the First Hospital of Jilin University between January and September 2016. 13 gender and age matched healthy volunteers were recruited. Peripheral blood was collected from all participants after an overnight fast. Flow cytometry analysis was performed on a BD fluorescence activated cell sorter. Within the peripheral CD3 positive, CD4 positive T cell population, Th22 cells were phenotypically gated as CCR6 positive, CCR4 positive, CCR3 negative, and CCR10 positive, and Th17 cells as CCR6 positive, CCR4 positive, CCR3 negative, CCR10 negative. Cells with a Th1 profile were gated as CCR6 negative, CCR4 negative, CXCR3 positive. Flow cytometry analysis indicated that the frequencies of CCR6 positive, CCR4 positive, CR3 negative, CCR10 positive T cells as Th22 cells. CCR6 positive, CCR4 positive, CCR3 negative, CCR10 negative T cells, Th17 cells in the patients with SLE was significantly higher than those in healthy controls. Furthermore, we characterized the functional subsets of the CD3 positive, CD4 positive T cells, which were stained with antibodies against different cytokines in cells. We found that the percentage of CD3 positive, CD4 positive, interleukin 22 positive, interleukin 17 negative, interferon gamma negative, Th22 cells in SLE patients was significantly higher than that of healthy controls. The frequencies of CD3 positive, CD4 positive, interleukin 17 positive, interferon gamma negative, Th17 cells in SLE patients increased obviously compared with that in healthy controls. Then we determined the Th cells population with double tagging, both surface and intracellular markers. Interestingly, we discovered the percentage of the Th22, Th17 cells was significantly greater than those in healthy controls. The correlation analysis was performed, and we have found the frequencies of Th22 subsets correlated positively with clinical indicators in new onset SLE patients. We stratified the patients into two groups: 16 patients with skin impairment and 9 patients without skin involvement. The stratum analysis revealed that the surface marked, intracellular marked, and double tagging Th22 cells was significantly elevated in patients with lupus skin diseases. And at the same time, the elevated levels of surface marked, intracellularly marked, and double tagged Th22 cells were correlated with RCLASI in the patients with lupus skin diseases. Taken together, our data indicated a higher frequency of Th22 cells in SLE patients, especially those with skin impaired, and the percentages of Th22 were correlated with the values of SLIDI and RCLASI. Our findings suggest that Th22 cells may contribute to the pathogenesis of SLE, and that frequency of Th22 may be valuable for the evaluation of disease severity in SLE patients. In addition, this study provides a functional link between the chemokine receptors and the interleukins, which have been independently associated with the T cell-mediated tissue impairment in SLE, and provides a new insights into the understanding of the pathogenesis of SLE in humans. Thanks a lot for your time, and hope you can have a great stay in this beautiful city, Melbourne.